Space is a very different place from Earth. In microgravity, there's no walking, no standing, and no real sense of balance. Every movement has consequences, and even a small push can send you drifting across a module. That means many of the designs we associate with robots on Earth simply don't make sense once they leave the planet. That idea is what inspired Orbit Robotics, a spin-out from ETH Zurich, to create Helios. Instead of building another humanoid robot with 2 legs and 2 arms, the team started with a simple question: why design for gravity when the robot will spend its life in a place where gravity barely exists? The answer is a machine unlike anything you've probably seen before. Helios uses 4 arms instead of legs. 2 of those arms are used to anchor the robot securely to surfaces inside a spacecraft or space station. While those arms keep it stable, the other 2 are free to work. They can move cargo, operate tools, reposition equipment, and handle other tasks that astronauts normally spend hours doing. This setup allows Helios to stay locked in place while performing precise work, something that would be much harder for a traditional humanoid robot floating in zero gravity. The engineering behind the arms is just as interesting. Rather than placing heavy motors throughout every joint, Helios uses a tendon-driven system. Most of the motors are located near the shoulders, while cables and pulleys transfer force through the arms. This reduces weight at the ends of the limbs and improves efficiency without limiting movement. The robot also features a special rolling contact elbow joint designed for smooth and controlled motion. That may sound like a small detail, but in microgravity, sudden movements can destabilize both the robot and whatever object it is handling. Before developing Helios, the team built an earlier robot called Icarus. That platform helped them test technologies such as teleoperation, imitation learning, and advanced to 2-arm manipulation. The lessons learned from Icarus became the foundation for Helios and helped validate many of the concepts now being used in the new system. Orbit Robotics says the goal is not to replace astronauts, but to support them. By taking over repetitive jobs, robots like Helios could allow astronauts to focus on more valuable scientific work. Research involving aging, cancer treatments, and even organ bioprinting in microgravity could benefit from having human crews spend less time on routine maintenance and logistics. Those routine jobs are surprisingly expensive. A significant portion of astronaut time aboard the International Space Station is spent on maintenance and equipment handling. Considering the enormous cost of keeping people in orbit, every hour spent sorting supplies or moving cargo comes with a staggering price tag. Helios doesn't need to solve every problem or make groundbreaking scientific discoveries on its own. It simply needs to move efficiently through tight spaces, remain stable without gravity, and manipulate objects accurately. Those are exactly the tasks it was designed to perform. The company also sees opportunities beyond the inside of space stations. Future versions could help service satellites, assemble structures in orbit, and support large-scale construction projects in space. As launch costs continue to fall and more commercial space habitats are planned, the demand for robotic workers could grow dramatically. Every new station, laboratory, or orbital facility will need maintenance, logistics, and equipment management. At the same time, scientists continue to learn more about the effects of long-term spaceflight on the human body. Extended stays in orbit can lead to radiation exposure, bone loss, vision changes, and other health challenges. These realities have fueled ongoing debates about whether robots may ultimately be better suited for many space missions. Orbit Robotics presents Helios as a partner for astronauts, and that's certainly its role today. But the philosophy behind its design raises a bigger question. Engineers looked at the environment of space and decided that legs were unnecessary, replacing them with something better suited to the task. Following that same logic leads to an even more fascinating thought. When it comes to exploring the cosmos, is the human body really the ideal machine for the job?